flat. Uh, we want to talk about pressure in liquid, part one. And first, when we are talking about pressure in liquid, we are actually looking at most textbooks will tell you pressure in fluids, but we want to focus on liquid and so that we can be able to narrow the course. Now, what we want to look at now, what is the difference between pressure in solid and pressure in liquid? Now, pressure in solid is that word, pressure only downward. Pressure in liquid is that pressure only in the downward direction. Pressure in solid, in solid is that what? Pressure downward. And it depends on the areas and the force involved. You check our last video, wonder when I did the introduction of pressure, go and watch that. Then, number two, what is pressure in liquid all about? It's what pressure in liquid is that what? Pressure in all direction. So exact what? Pressure in all what? Direction. In all direction. That is the difference between liquid pressure and what? Solid pressure. That is to say solid itself. Solid exact pressure downward, while liquid what exact what? Liquid exact pressure in all direction. Now, first, we have been able to know or we are able to conclude how to differentiate between solid and liquid. So solid, pressure downward, liquid, pressure in all directions. Now, what is the characteristics of pressure that is in liquid? Now, we want to look at the characteristics, the behavior of pressure in liquid. So we are focusing on pressure in liquid now. So I just only differentiate the two of them. Number one is that pressure in liquid increases with what? In depth or in direct proportional. You can let us put it direct proportional to the depth of liquid, of the liquid. So that is number one. Pressure in liquid increases in direct proportion to the depth of the liquid. In other words, pressure is proportional to the what? Depth. Let's use what? H of a particular liquid. Now, let me give you one very good idea about it. There is a difference between depth and height of the liquid. Now, pressure what? Increases with what? With depth, but what? Decreases with height. Now, when we say pressure increases with depth and what? Increases with height. Pressure what? Increases with depth and what? Decreases with what? Height. Now, we said what characteristics of pressure in liquid is that pressure in liquid increases in the direction proportional to the depth of the liquid. And we also say that what? That pressure increases with depth but decreases with height. Now, if I draw a vessel, I draw a vessel and place it on a laboratory table. I place it on a laboratory table. Let's say this is a table. And let me pour water, let me pump water into it, plug water into it, and let water be plugged into this vessel. so that water can enter into the what? The vessel. Now, after water has entered the vessel, we want to see how pressure increases with depth. So this one is what? A demonstration of what? Liquid what? Pressure increases with what? Increases with depth. So that is what we want to do. Now, when we have filled this place with what? The vessel with water. Now, what we want to do now is to what? The next thing to do is to fit the pipe. Let's say what? Number one, we say this is what? A simple demonstration. Demonstration by means of what? Of full what? Of what? A tall what? Vessel full of water with what? Tube what? Fitted at different what? Heights as shown above. Now, what we did now is that let's open this up, fill it with what? Open there, then fit it with what? A tube. Let me call this one A. Let's call this one A. Let me open this one on that side again. This one is A. Let me open here and call it what? B. And let me open this last place and call it C. This B. And call this place C. Now, this is what? The container where the vessel where the water are what? Entering. Now, what do we notice? We notice that this now, we notice that the speed of C is what? Greatest. That means the speed which water was poured out. The speed, let me put it like this, the speed with which what? Water spurt out from what? From C is the what? The greatest. For the lowest what? Lowest tube. That means the tube at this point C, with the speed at which water spurt out from there is the greatest. That means that the C produces a what? A pressure that is higher than what? B. That the pressure of C is greater than pressure of B is greater than pressure of A. So that means to say that pressure what? Increases with what? Depth and decreases with height. Therefore, what we are saying now is that because at this point now is very close to the surface of the water. This is the surface of the water. This is the surface of the water. Now, the surface of the water. So at the surface of the water, the tube, the hole here, or the opening here at A is closer to what? Or is the closest to the surface of the water? To the surface. The closest. Comparing the three of them. Then followed by what? B. Then followed by C. So C have a what? A higher depth compared to what? To what? To A and B. So we have proved that what? Number one, pressure what? In liquid increases with depth. Number 2 point is that pressure in liquid is what? Direct what? Is in direct what? Proportion to the density.
of what? Direct proportional to the density of what? Different what? Liquid at the same what? The same level. That is to say, pressure in liquid is in direct proportion. That means to the density of different liquid at the same level. That is to say, pressure is proportional to what? Density. So the higher the density of a liquid, the higher the pressure. The higher the density of a liquid, the higher the pressure. So please take note of that. Pressure in different liquids at the same level varies what? Directly with what? Density. That's what I mean. I mean what? Pressure in different liquids what? At the same what? Depth varies what? That's what that is. Pressure in different what? You can put it that way. Different liquid at the same what? Depth varies what? With density. So that is to say that pressure in different liquid, if you bring what? For example, different liquid. For example, if you bring what? Water, and you bring kerosene, and you place a what? You want to consider the same level for the two of them. Let's say you fill the container to the same level. You understand now? Of the two what? Vessels. This is the two vessels. Now, these two vessels are now filled to the same level. You understand now? Now, let us consider the pressure at this position of the two of them. Pressure of the two of them at position A and A of the two of them like this. Now, we notice that what? The pressure of the water will be higher than pressure of the kerosene. Why, class? At the same level, they have the same depth because we take the same level for the two of them, taking kerosene and taking water. Now, from our look of things, kerosene should have a lesser density than water. Kerosene should have a what? A lesser density than water. So since it's what? Having a lesser density with water, the pressure of what? At this level of water is higher than pressure at the level of kerosene, simply because the water has a higher density than what? Than kerosene. So that is to now conclude the second characteristics of behavior of pressure in liquid is that pressure in different liquid like kerosene, water and kerosene, at the same depth, considering the same depth from the top to this place, from here to this place, and from here to this place. That means if you consider their depth from the surface, because the depth is measured from surface downward. Don't forget. So you consider the surface from here, from this surface now, also downward, the same depth varies with what? Directly, you can put it directly. Varies directly. You can put it directly here. Yes. Directly is missing. You know why? Because this is a direct variation. Increase in pressure will lead to increase in density. Increase in pressure will lead to increase in density. Let's clear this part. Now, the next thing we want to talk about is what? The third characteristics of this is what? Pressure in liquid, what? Is what? Independent of what? The cross-sectional area. Cross-sectional area. pressure in liquid is independent of cross-sectional area. Now, if you check the formula for pressure, we are going to see it how it works. Is actually what rho GH. I'm going to show you how it comes about, how we derive the formula. We are going to rho GH. Sometimes we can call it DGH, which is density times gravity times height or depth. Now, if you check this formula, it does not depend on area. It is not by the size of the vessel that pressure depends on. It is not what? Depending on anything that has to do with cross-sectional area. But if you talk about pressure in solid, fine. But pressure in liquid, it does not depend because it's act in what? In all what? Direction. Now, what if you have a container? You know, if you have a container like this, now let's say this is a container now, or this is a cylindrical shape or a can. Now, if you take an empty can, for example, now, you understand that? You cannot say pressure depends on the what? The area of this can. No. Now, if you fill the can with liquid, fill the can with liquid. Now, when you now open the what? Put an opening, create an opening with a nail around the what? The can. When you create an opening around the can, you notice that there will be a what? There will be a what? Spot out of what? Of this liquid from those holes around it. That is to say, there will be spot out of liquid. That means the liquid will be pumping out from those holes. Ensure they are identical holes. That is, we are going to notice that pressure acts in what? In all directions. Pressure acts in all directions in liquid. That is number 4. Pressure does what? Act in all directions in liquid. You start pumping out from that hole because you have created what? A hole, identical hole around the can that you filled, empty can that you filled with water. And you now nail it, you put a nail to what? To create a hole, identical hole around the can. What you're going to notice that the water will begin to pump out from those holes in all the directions surrounding the can. It shows that pressure what? Act in all what? Direction. Then the number 5 one I will give is that what? Pressure depends on what? On gravity, acceleration to gravity. So if you check the formula now, I've given everything that we need to know. If you check the formula, you can actually bring 3 things out from that formula. You can actually bring 3 things out from that formula. What can you bring out from that formula? You can bring out that pressure depends. Note that pressure what? In summary, pressure depends on 1. What is number 1 there that you can see from the formula? Even from the formula, you can always maneuver it. Density. That is number 2. Depend on acceleration due to gravity. Due to gravity. So for examination's sake, you can always remember with that formula. And the H here is what? Depth. So pressure depends on acceleration due to gravity, depend on density, and depend on depth. Now, the study of pressure in water is what we call hydrostatic pressure. The study of pressure in water is known as hydrostatic pressure. So in the exam, when they say pressure in water is also known as dash. So pressure in water is called dash. Please take note of that. It is called what? Hydrostatic pressure. You can come that way. I put it that study of pressure in what? In water is called hydrostatic pressure. I put it that way for you so that you can know it. In any way the question will come out, please just take note of that in any exam you want to write. Please take note of that. Very important. Now, having known that, now there is something I want to give you now before we go to calculation, because we have. I want to discuss some applications, but we want to talk about calculation. But before we talk about calculation, I want to talk about the derivation. I want to talk about what? Derivation of what? Pressure in liquid. How do we derive what? The pressure in liquid. Now, recall that pressure equal to force over area. Now, if you check our last video, go and check it. This is a continuation class. So help us to help you so that you can understand, because physics is all about there is a build-up on whatever you have learned before concerning that particular thing. So that last class video, go and watch where we talk about something. I gave you, I said this particular F is got what? Mg over A, if you remember. Mg over A. Let's assume that this is a container now. This is a container. Now, it has what? A height. Okay, let me even take it as a what? A square container like this. Let me take a container like this. Now, if I consider this container like this is a container. Now, this container now has a what? A particular what? Height. And that height is H. It has the length and the what? The breadth. The length, I can put, let me call this one length and the breadth. Now, the mass is equals to what? Mass of the what? Let's say we fill it with what? Water. Let's say we fill the container with water, for instance. You fill the container with water. Don't forget, this is a what? This container volume is what? Length times breadth times height. Don't forget, it's a cubion. It's a cubic what? A cubion what? A rectangle, what we call a rectangular block. Anytime you hear what? A rectangular block, you are trying to refer to a shape like this, which is a cubion, which is length times breadth times height. Now, from the knowledge of density that we have also treated, go and watch density video. We know that's what? Density, mass equal to density times volume. Recall that density equal to mass over what? Volume. Now, if you make mass the subject of formula, we have density equal to, or mass equal to density times what? Volume. Now, having known that, now making mass the subject of one formula, you have got density times volume. Now, put it in that formula. What do you have? Pressure is equal to what? Density. Instead of mass, mg over A, we now have it as what? Density times volume times gravity over A. Now, something we have to note. Remember that volume is equal to what? Length times breadth times height of the container. What is area? The base area, this is the base what? Area of the what? Of the vessel. The base area of the vessel. The base area. What is the base area of the vessel? The base area of the vessel. This is the base area of the vessel that we are considering. This is the base area of that vessel. And what is the base area of that vessel? It is what? Length times breadth. The base area is length times breadth. Now, if you now consider that as length times breadth, which is the base area, now let us place it there. Let's place it in that formula accordingly. I would have pressure equal to what? B. In place of volume, let's do what? Length times breadth times height. Then times what? G. divide by what? What is our area? The base area. The base area is what? Length times breadth. Then this one will cancel that. Then what we have now? What do we have? What do we have? This one becomes what? Pressure equal to what? Density times what? H times G. Please take note of this formula which I have given. So that means that what? Density, that means what we call rho GH. The same thing, they can use density instead of using D, they use it as rho. So that is just that. That is density for you. So now, if they give you relative density, which is specific gravity, you can convert it to density. They use it to solve. Don't forget, if they give you specific gravity, you can always convert the specific gravity to what? To density. Specific gravity is what we call the what? Relative what? Density. I've told you how to convert relative density to what? To density. I've told you how to convert what? Relative density to density. Density can also be called the mass what? Density. The mass density. Because it's mass over volume. Now look at the board. Now there's something I want to show you. Let's say we have, okay, let's take a question to that effect. Say calculate, example 1. Calculate the pressure of water. Calculate the pressure of water at the bottom of dam 300 what? Meter deep. If the density of water is what? 1000 kilogram per meter cube. Take G as what? 10 meter per second square. Now they say calculate the pressure of water at the what? The bottom of dam 300 meter deep. You must ensure that your depth is what? Is in meter, so that you can go alongside with what? Acceleration to gravity, the standard unit. So what is pressure? Pressure is equal to what? Rho density times gravity times height. That's the formula, or times depth rather. So it's what? Density times what? G times depth. So what is our density now? 1000 times what? 10 times what? 300. So we're going to have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that means we have 3 times what? 10 raised to the power of 6 Newton per meter square. Or 3 times 10 raised by 6 what? Pascal. That will be your answer for that question. So if you write it in Newton per meter square, it's the same thing as writing it in Pascal. Now, before we what? Solve, before we take out, let's take this other one again. This one is a little bit technical. Let's see. After this one, I will now talk about atmospheric pressure, because we need it to solve. Sometimes they will give us atmospheric pressure. Then how do we relate it to calculating pressure? That is another thing. Atmospheric pressure. I think that is going to take us a little while. And I think that's where you are going to end for today, because time does not permit us. Example 2. He said what? The base of a rectangular what? Rectangular vessel. What I just used now to do this proof is rectangular vessel. Measured what? 10 centimeter by what? 18 centimeter. Full stop. That is the rectangular base. This is the length and breadth. Then that's it. Water is poured into the depth. Into a depth of 4 centimeter. What is the pressure on the base? That's number one. Then calculate the force exerted on the base. Don't forget that once you get your pressure, don't forget pressure, you now to get force. Force equal to what? Pressure times area. And the area we're talking about is the base area. The base area, this is the area we're talking about here. So whenever you get your pressure, you can calculate your force by multiplying your pressure times the area, the base area of the vessel. Don't forget that. And that's what I want to use, because I think I'd not finished it here. I didn't tell you how to find the force exerted on the base area. The force will now be equal to what? Pressure that you have, the rho GH times area. So somebody can say, okay, what if I write it as what? Rho GH times area. It's correct. That is pressure for you. Rho GH times area. That is it. So please take note of that. The force exerted. Don't forget force. The force there is what? Depending on the area. But the pressure does not depend on area. Recall, the force here is a gravitational force. The force involved here is not just ordinary force, but a gravitational force. What is a gravitational force? A gravitational force is a force that acts on a body, and what tends to what? Act towards the what? Direction of gravity. It is the force, force that acts on the body and tend to push it down to the what? To earth. That is to say, it's always in the direction of the earth. And if you check, when I told you, I said solid exert pressure in the downward what? Direction. That is to say, where does force, gravitational force, act? In the downward direction. And that's what when I explain about pressure having a what? A lesser pressure when area is what? A large, last week class, and you have a lesser pressure when your area is large, rather, and you have a more pressure when area is what? Small. And I gave you an example of an insect. I will give an example of an elephant. Elephant is exerting what? A very lesser pressure on the ground, a downward pressure, because it has a larger what? Area, the legs of an elephant. So please take note of that. Now, I want to watch that video, very interesting video. Pressure in solid. Now, let us now solve this one now. We want to solve. Now, don't forget, when you are solving, you use what they call DSS. DSS means data. Check your what suitable formula for that question. Take a suitable formula for the question, then you solve. Now, they say the base of a rectangular vessel, 10 centimeter by what? 18 centimeter. So the area is equal to what? 10 centimeter times what? 18 centimeter. That is base area. But there is a conversion needed here. What do? To convert centimeter to meter, you divide by 100. So that will give us what? 0.1 meter times what? Divide this one by 100, we have what? 0.18 what? Meter. That's what I want to have. Now, which is the same thing as what? Is 18 times what? 10 raised to the power of what? -3 meter. So that's what I want to have. Now, having gotten that, we can say 0.018 meter. Is still correct? Square. Now, having gotten that, water is poured into the depth. What is the depth now? The height. The depth. The depth is what? 4 centimeter. And if we convert 4 centimeter to meter, what do we have? We are going to have it as what? Divide by 100. You have 0.04 meter. If you are solving, just press your calculator to follow me up. Now, what is the what? The pressure on the base. The pressure on the base is equal to what? Density times gravity times what? Height. The pressure exerted on the base is what? We have told you how we derive this formula. Don't forget, we use the area because we are trying to know the pressure. The area we use was the base area. So whatever this one is solving is pressure at the bottom. They can use that word pressure at the bottom or pressure at the base. Now, the pressure at the base is what? Well, what is the density there? The density of the what? Of water, they didn't give us, but you can take density of water to be what? The rho of water to be 1,000 what? Kilograms per meter cube. What to give us? Then the height, the gravity is what? 10 meter per second square. So that's why we have to convert to standard unit so that we can solve. Now density is 1,000 times gravity is what? 10 times what is our height here? Our height is what? 0.04. What do we have? We want to have it as what? This 1,000 times 10 times 4 over 100. So cancel this, this will cancel this. So what I want to have is 10 times 10 is 100 times 4 is 400 Pascal. So pressure is 400 Pascal. Now, or 400 what? Newton per meter square. Anyone you want to use. But that is not our final answer. That we have solved number one question anyway. This is Roman figure 1. Please take note of that. That's Roman figure 1. Now the number 2 says what? Find the what? The force. What is what? Force exerted on the base of the vessel. The force exerted on the base of the vessel is equal to what? F equal to, don't forget, pressure equal to force over area. Then you cross multiply, you have force equal to what? Pressure times area. Now, what is the base area? The base area is what? This, which is what? A. Then what is the pressure? 400. So we would have what? 400 times base area is what? 0.018. That's what? 0.018. Then if you do that, we are going to have it as what? 2, 7, there's 7.2 will be your answer. I would have 7.2 as your answer. So you can check with your calculator. That will be 7.2 because this one is 18 over 1,000. 18 times 4 is 72. Then 1,000, if you remove this one now, 400 times 18 over 1,000 is what? This we cancel this, this we cancel this. Then 4 times 18 is 72. 72 divided by 10 is 7.2. That will be your answer for that one. So we are able to solve the what? The force, and we are able to what? Solve for the pressure. Now, we want to relate pressure with atmosphere. Atmospheric pressure. We want to talk about what is an atmospheric pressure. What is an atmospheric pressure? That is what we are going. This is the last part. Once I explain atmospheric pressure, we will now relate pressure with atmospheric pressure. Well, how does they relate? Because sometimes we say atmospheric pressure do act on the what? On the liquid at the surface. And it tends to increase it and decrease it. Atmospheric pressure can either increase the pressure and what? Decrease the pressure, depending on the what? On the position of the what? Of the depth. So that don't forget, it increases with depth, but decreases with height. I told you before from the beginning. Now, the atmosphere has a what? When we talk about atmospheric pressure, atmospheric what? Pressure. The atmosphere has air, and that air has a weight. The atmosphere has air, and that air has a weight. And owing to this weight, the weight exerts a pressure on the surface of the earth. That is what I'm saying now, is that there is a air, and this air has a what? Weight. And this weight now, which is W. Now, owing to this what? To its weight now, the weight of the atmosphere. The atmosphere now Eh? Because weight is already involved. We now exert a what? A pressure. Once weight is involved, pressure will come in. Don't forget, weight brings about gravity. And once gravity comes into play, the pressure will come in. You cannot separate gravity from pressure. Don't forget, the higher the gravity, the higher the pressure. The higher the gravity, the higher the pressure. The pressure on the mountain is lesser than the pressure at the sea level. The sea level we are talking about, anytime you hear physics talk about sea level, the sea level is the surface of what? Surface of the earth. Below the sea level is below the deep sea. That means where fishes and deep fishes are reside. Below the sea level, that means below the surface where we are, where we put our legs on. So that's what we call what? Below the sea level. Why we call it sea level or the ground level? It's because the Bible says that everything was made sea before God separated the earth, the sea from the land. You know, so everything was sea. So that's why scientists borrow that word from the God of science, which is God himself. So sea level is a ground level. Anytime you hear sea level, you are referring to ground level. Please take note of that. Very important. And because the air has a weight, owing to this weight, the atmosphere exerts a pressure. So it is now called, this pressure is what? Is called what? Atmospheric pressure. Pressure that is exerted by the atmosphere. Now, having known that now the value is what? Approximately equal to what? 10 raised to power 5 Pascal. We are going to see how we get it. Normally, the real value should be what? 101,325 Pascal. That is normal value. Or 101,325 what? Newton per meter square. So this is normal, but approximately this is the value of what? Atmospheric what? Pressure. So the atmospheric pressure acts at the surface of the what? Of the earth. Now, if you want to demonstrate what? The action of the atmosphere, I will give you to do and do that because time will not permit us to do that demonstration. No, I want to go and do that. You understand? I will just explain it and how what we can demonstrate what? The influence of atmosphere on the what? On the body. Now, let us have a can. If I will just explain it, demonstration of atmosphere on the body. Let us have a can that is fitted with air. Now, there is a large force that will be acting on the can due to the atmosphere. Now, let the can be what? Fitted with what? Air. Now, let us remove the can. If you remove the can, now what? Pull what? Attach it to a boiler, a Bunsen burner. Then why do you attach it to a Bunsen burner? When you feel it, you what? Put in where water enter, remove the what? The stopper, the tight stopper, and what? Let water enter. The airtight stopper, let water enter the boiled water, let it enter it. Don't forget, boiled water. Water boil when the atmospheric pressure equal to the pressure of the water. Now, that means that we want to have a steam water here. Now, at this point, now, when you have the steam water inside the can, now I want to do something now. I will now remove, after we have the steam water inside the can, at this point, the atmospheric pressure to what? The pressure of the water inside the can. Now, I remove the can. I put water and I put what? Boiled water inside it. At this point, the atmospheric pressure on the what? Outside equal to the pressure inside. So it balance. Now, let me pour water. Before I pour water, remove the what? The burner. Immediately or simultaneously pour what? Cold water on the body of the can. You will notice that the can will collapse. When will the can collapse? You can do it at home anywhere. You can have an empty can, that empty can, expose it. Let it be air filled what? Filled can. You can expose it and fill it with air. Now, when you expose it and fill it with air, have you ever matched or stepped on a what? A pure water nylon? I know Nigerians will know what I mean by pure water nylon. Those of you that are watching me from abroad, might not know. But we have what they call pure water nylon. It's a nylon filled with water. Now, when you empty it, how many of you have stepped on it, on a water that have been drank by someone and placed on the ground, just exposed to the atmosphere? Sometimes when you step on it, you hear a loud sound. You just hear as it pop. Now that sound is what? Is a force influence, because of what? The pressure of the atmosphere is no longer balanced with the pressure of the what? Of the filled what? Substance in that nylon. So when you remove the steam or leave the steam, pour cold water, and before you do that, you remove the post burner and immediately pour the what? Burner there. You will notice that it will collapse. This thing, the burner, the airtight or this thing will collapse. So it will not look like something like this. It will not collapse. It will no longer what? Because what? The pressure outside is higher, is now what? Higher than pressure inside. They can ask, why will the what? They can't collapse. It's because the pressure outside, the atmospheric pressure, is no longer balanced with the pressure inside. Initially, it was balanced because of the steam water. But when you pour the cold water, don't forget to reduce the pressure inside. And as such, it will now what? Make the atmospheric pressure, the pressure outside, the air pressure outside the can, to be higher than pressure inside. So that is a demonstration of how atmospheric pressure works. Now, basically, I will give you this formula, but you will apply it in the next class. This class, pressure in liquid, will take us almost 3 parts because we are using 1 hour. If I don't want to write a rush course, it will take you up to part 1, part 2, part 3. Don't forget, the one I did last week, or the last class I did, was an introduction to what? Pressure in solid. We actually started pressure now. We just started pressure now in liquid. Now, let me do this one so that I will end here. I want to do something here. Let me have a what? A container. This is where I'm going to end. I want to bring out a lot of formula from here. Please, that's where I want to take a lot of questions. Now, let me take this is a surface. I'm filled with what? Liquid. After this analysis, please understand this analysis because a lot of questions do come out from there. Now, let's call this one A, and let's call this point B. This is the last analysis. Now, let's say it is what? A water or mercury. Let's fill it. So let's take water, for instance. Now, this point B has a what? A depth of what? H. Please take note of that. Has a depth of H. Or let me take it as mercury. Let me mercury. Now, if I want have it as H, for instance, the depth. Now, pressure in A is lesser than pressure in B. And let me take a point here. Let's call this one C. Pressure in C is lesser than pressure in A, because this one is above. The more you are moving up, the lesser the pressure. The more you are going higher, the lesser the pressure. Pressure in C is smaller than pressure in A, and it's smaller. This B is what? Higher than pressure in A. So pressure in A is equal to what? Atmospheric pressure. Please take on. Pressure in A is equal to what? The atmospheric pressure. Please take note of that. Very important to know that. Now, pressure in B, let's call it what? ATM. Pressure in A equal to what? So pressure at the surface of that liquid there is equal to what? Because the pressure atmosphere acts directly with the surface. The atmosphere is what? Is acting directly with the surface. Yeah. of the water, of the mercury there. But below the what? The depth, below B. The pressure at the B, at point B below, at that depth, is equal to what? The pressure in A plus what? Rho GH. Please take on that. The pressure in B is equal to what? Pressure in A plus what? Rho GH. That means the density of the liquid of mercury, the density of mercury, times the gravity of what? Of the what? Given to us, because gravity is acting on this one too. If the gravity is acting on, then G, and that means depth. How many of you have ever put your head on the pressure is at the surface is lesser than pressure at of water? If you put your face at the surface of water, I believe you enjoy it. But let somebody dip your hair as if they want to baptize you below the water. After maybe like 10 seconds, you will not be comfortable. You will shout because pressure at that point is higher than pressure at the surface. Somebody can put your face at the surface of the water and you begin to enjoy it. Immediately the boy just looks that you are enjoying it and he drop your head down into the water. Before you know, after 5 or 10 minutes or 10 seconds, you start shouting. That thing can even kill somebody. If they put somebody's face on inside the water for long, it might not survive it because pressure increases with depth. So that is it. I will stop here. Let me give you pressure in C. Pressure in C will be lesser because pressure in C will not be what? Pressure in A minus what? Rho GH. Let's take on that. That is to say, pressure at A is equal to atmospheric pressure. Pressure in B, we add what? The Rho GH. We call it pressure gauge plus atmospheric pressure, or the pressure due to the liquid at that depth plus atmospheric pressure, better still. Then pressure above the surface of the water is what? Atmospheric pressure minus Rho GH. This one is not too common, but I believe you are familiar with this. Then the pressure at the surface is what? This one. Then this one above, maybe you now consider this above. So that means as you are moving above, pressure drops. So in our next class now, because this is 9 on the dot, because I want to take a question before, but I don't think I can take a question to back this particular thing up. So in our next class now, we are going to see question on this particular analysis. I don't know if we have 1 or 2 questions to ask for just 2 minutes before we go. If you don't have questions, you are supposed to be typing your question if you have any question concerning it. But calculation question, you have to wait in our next class we solve. But although this class will take us to part 1, part 2, and part 3, because it's very wide. We are going to talk about fringe, talk about what bicycle pump, talk about brakes, talk about pump, you got bicycle pump, we talk about a lot of things I want to talk about. We are going to talk about manometer, we talk about simple barometer. We are going to talk about, because after talking about pressure now, which I've explained, we are going to know in our next class what is the instrument used to measure what? Atmospheric pressure. We call them what? Barometer. And we have 3 types of barometer. We have what? The simple barometer, we have the faulty barometer, and we have the aneroid barometer. All those are we're going to look in the next class. Please help us to share this particular video and help us to also communicate people. Every Wednesdays and Fridays, we always have class like this. It has become a norm and a program that everybody that want to build his physics class or business knowledge should engage this channel, and also make sure you are following. And I believe by special grace of God, by God's grace, you will understand every bit that we have been doing, and you see yourself improving in physics by His grace. Thank you very much. I remain Engineer Halidi. I want to say good night to every one of us. God bless you. Thank you.